Hello everyone. Today we are going to talk about ASP.NET Core hangs. Oh, what is a hang? Hang is when you send request to a server and server doesn't respond in time, and when you send another request and server doesn't respond in time, and you are getting a lot of errors in the logs. So requests are basically not coming back. It's just hanging there. The CPU is still low. The memory utilization is still kinda okay. So that's what the normal hangs look like. So why ASP.NET Core hangs? What are the most possible causes, right? What causes it? So there can be many scenarios, but I'm oversimplifying it. Sync over async, like you're using an async method like sync wave. For example, you're using dot result, or you're using get result, which can cause hangs. Not always, but with little bit of load, yeah, you might encounter it. Thread pool configs. What are the thread pool configs? If you're using sync over async and you can't really convert it to async all the way, then you should look at thread pool configs. Did you know that you can override them? We're gonna look at that. Or you are getting burst load. Burst load is like you normally expect 100 concurrent users on your website, but suddenly one of your video got viral, or one of your tweet got viral, and now you're getting 1000 concurrent users every hour, and it is causing issues in your application. Or you are relying on a third-party service or even your own service, which is acting up and responding slow, and thus causing issues in the upstream services, like in your main service. So these can also cause hangs, but it all comes down to if you are making a mistake of blocking a thread by using sync over async, or you are using a third-party API where you only have sync methods available, so you have no option. These are some of the possible causes, not all. So we're gonna look at this specific use case today. Now, how you will diagnose it, right? If that happens, you have a service running, CPU is balanced, it's like 30% on your hosts, or one host or multiple hosts, if you are behind a load balancer, but the application is throwing a lot of errors, or it is not even logging something sometime. So what do? You can use some of the paid monitoring tools. For example, in my company, we use Diagnose, which is pretty good actually. You can use Datadog or some other paid tools. They have nice profiler, which can watch your application 24/7 and give you nice hints and nice traces to look at it, and they help to contextualize the problem. If you don't have any of that, .NET got you covered, I think. .NET has many diagnostic tools. Let's look at them one by one, which we're briefly gonna touch in this video. .NET Counters. Counters is a pretty good tool, which can provide you what is going inside your process. Like you wanna see how much CPU this process is using, how much memory this process is using. As far as this video is concerned, we are more concerned about the thread pool counters, like how many threads are in the queue, how many threads are currently executing. We're gonna look at that, and I will show you how you can watch specific counters as well. Then we're gonna look at the .NET dump. You can trigger dump on certain conditions. You can take full dump. Today we're gonna take a full dump of the memory, and then we will analyze it and see what is inside that memory dump. And then there is a .NET trace, which is helpful or beneficial if you have a high CPU and you have slow responding endpoints, you want to diagnose it, that what is eating all that CPU and what is causing it, then .NET Trace can be really helpful. You can open it in Visual Studio, or you can open it in Rider. There are some open source tools available as well. Then there is a tool .NET Stack. If you want to analyze the thread, when you debug, you see the stack of the thread, right? What's going on, how it is coming to the point where it is. So you can analyze a running process by dumping all the stack traces of the threads. These are all free open source tools by .NET. So use case, we're gonna look at the use case specifically. Why WCF? People usually forget about it, but a lot of legacy applications are still using WCF in some form. In this specific case, I was looking at one of our internal application, which was hanging or causing issues under load, and I really got intrigued by it, that what is causing it. Especially it is migrated from .NET Framework to .NET 6. So I started looking into this, which resulted in this video. So you're migrating an application from .NET Framework to .NET 6 or 7, or soon coming .NET 8. But in your legacy application, you are using sync methods. Either you are mistakenly using it, or you don't have any choice. For example, you have a third-party API which only provides sync method. So yeah, you have no choice. But in this case, WCF does have a choice, because when you're using any SOAP service over basic HTTP binding, it provides you both async and sync methods. So your client, the consumer with your application, if you want to go all the way to async, it won't be impacted by the blocking of the threads. But legacy applications can be really hard to change. If you have maintained a .NET Framework application for a long time, you would know that it is not easy to change an already stable application all the way to async. It requires a very significant effort, very significant testing, and especially when you have paid users, you don't want to break them. So you might end up feature flagging and slowly converting those. But what do you mean while? Like, if it is not all sync, can't you release any of that? Are you going to hold the release for a long time? No, right? So in this video, I'm going to show you that how you can have temporary relief, or for some applications, permanent relief. Because you know your load, you know that your load is not going to be exceed X expectations, and you have already tested it, so it's fine. You don't want to invest any more time into it. But yeah, happy to, if you are, you just want to improve your code base, you can convert it always. And other issue is this, that, when you use application, the issue only happens when the application comes, load comes in bursts, like users come in early in the morning all at once, and, you are scaling, but so it's 1 hour, one of the hosts is still failing. So we're going to look into that. Let's go back to the Rider. I have prepared a small application for you. Let me give you an intro to that application. As I told you, I talked about the WCF service, so I just prepared a very simple WCF service, which I have a get data method, and I intentionally put this delay here just to mimic that this service will respond to the clients within 30 milliseconds, right? So no service is gonna be instant, right? So let's assume that this is the WCF server, very simple one. Then I have a Docker file which runs it in Docker. We will come to that. Then I have, this is the consumer application. In the consumer application, I have added this service here. This generates a proxy. As you all know, you can look at the proxy here. One thing I want to mention, when in the Rider especially, if you are generating a proxy and by using this client, so by default, the Rider will only include packages version of 4.xxx, which has significant difference between 4. and 6.00. especially if you are using singleton client. In 4.x, singleton always blocks the previous call, like it's serial calls. If video is not going to be too long, I might show you that behavior as well. But let's look at this minimal API. It's a very simple server. I'm listening on the port 80, and then I'm using a singleton client here, that ping service client I generated, I showed you here. And then this is another way of I am introducing a pool of the singleton ping service client, which I'm going to use in another endpoint, just to compare how these two will behave. This is just turning the caching on of the WCF proxy generated client. The root is hello world, and then there is a thread pool config. Thread pool config is just printing out what the runtime thread pool looks like via an endpoint. I just want to see that how thread pool is configured. Anyway, what is thread pool, right? Thread pool is a pool of threads. So .NET runtime basically have two types of threads mainly. Worker threads, which as soon as the request land on your servers, those requests are carried out by a worker thread. So if you are going all the way sync, it is blocking that thread all the time. Like that thread won't get free until it sends the response out. And another type of that is IO thread. IO thread is something which is, you got a worker thread and now you are using async state machine, then it hands over to the IO threads, which reads data from any other service, from some socket or from service, different protocols. So these are the pool threads. So there is a very important detail here we will see when we will observe it actually, that how .NET Runtime introduce new threads. So if you can see here, I have minimum threads and max threads. I can set it as I want by using thread pool dot set max threads and min threads. You can see that there are two worker threads and completion port threads. In .NET Framework, these are called input output threads. You can set in .NET Framework either using the machine config, or you can set it in the code as well. But it will be it is not per pool, it is across all the hosts. Here I think it is by the each .NET process. If you want to run this application, let me run this. I have this nice Docker Compose here. The code will be available online. So here we go. I started this. Is this running? This is running. Let's go to the endpoints here. I just want to see this open in editor. So my 5003, because if you look at the Docker Compose here, so this service is exposing port 5003 out to the outside. If I run it, so I'm gonna get this. You can see that by default, since my Docker is allocated with the 6 virtual CPUs, so it minimum threads are 6. I don't know why this is coming as 1. This should be 6 as well. And so max worker threads are 32,766 and IO threads are thousands. And these are the last method, is the get available threads here. This is what it is printing out. So this is what our thread pool config look like. Now let's get to the main business here. So here there is you can see that this is a get endpoint. It is called singleton. Why? Because I'm here using a singleton client. So if you can see up here, I'm registering into the DI with the basic with the 2 seconds send timeout and receive timeout. And remember that ping service only blocks for 30 milliseconds, right? Let's come back here. So it's a very simple call. I'm just getting data and then printing the result. And let's go back to the endpoint and see what does singleton do actually. So we're gonna do that. No, it's 5003. So response is okay. let me move this. Okay. So this is the response replying to you. Your ping, this is a random number and this is a pong, right? You can read it here. So get data. Here, if you go to the ping service, this is what it is returning, and it is coming all the way back. Okay. Now I'm gonna introduce you to I don't use that daily. I'm using that tool because I'm new to Mac. On the Windows machine, you can use Bombardier to throw some load on the let me move this to here. On your server here, I'm saying, okay, this is an endpoint. I'm just gonna say go easy on it, and I'm gonna say here 10 seconds. So we're gonna send a load for 10 seconds, one request at a time, and see what it does. And then I'm gonna take you to the Docker here. Here you can see that the log is running. So request finished and all that. Go back to writer. It says, okay, I sent 200 requests and all of them were okay. 100% succeeded, right? Now let's increase the rate to 6 per second, right? So 6 per second is sending. We're just gonna wait 10 seconds here, and we can see the logs here churning here. And now I'm gonna show you, I already installed the tools. Echo that. How did I install the tool? If you look at the Docker of this file, of this service, here I'm installing dotnet tray, monitor, dump, counter, and stack. So all those tools are available at the root path for me. So that's why I did connected to the terminal. Now I'm gonna go here and say dotnet counters monitor monitor dotnet. Okay, dotnet is the name of the process, and here we're gonna come back here. Let me just jump to the code, and here I'm gonna throw the load for the 10 seconds. Let's see what happens after that. You see all those controls are displaying here. These are the three settings I want you to focus on. See how requests are coming, and then I can see the thread pool, thread count, and then if there is a queue, that means that these are the worker threads running, and this is if there is some thread is waiting to get allotted a thread. That is a queue. So we send request set queue length. So .NET runtime introduced thread when the minimum thread pool is reached. It introduced a thread after X amount of time. I do not know the exact time. I think it's per second. Each new worker thread will be introduced. But let's go back, and now we have enough successful responses. I'm gonna just go ahead and say that let's go by 100 and do it by 30 seconds, right? 30 seconds. Let's see. Now look at this one. See that how many now the thread count has increased to 9. Occasionally we are seeing that the queue length was 1 at a time, but now the .NET has scaled its thread appropriately. Thread pool is sort of complex. It looks at the memory pressure as well and the CPU. I'm not certain, but it looks at all different factors to determine the heuristic that how .NET runtime is gonna inject the new threads. Usually it's based on time, right? That once minimum threads are reached, then every new thread will be introduced based on certain parameters. I simply think that it is introduced if you don't have a high CPU. We can see that CPU is 0 literally, and if you don't have a memory pressure, then it is gonna be a fixed amount of time a new thread is gonna be introduced. So it's already, I think, 30 seconds. We saw that it sent 3,000 requests here. Let me just make it a little bit bigger so you can see. Now I'm just gonna slowly, I'm gonna say, let's go maybe 500 and let's try to break it, right? Let's go back. See, all of a sudden, now we are saying, you see the thread pool? So all these threads are waiting for worker thread to get allotted. And thread pool thread count is 18, 19. You can see, so dotnet monitor is getting all those counters every second. So that's why you can see every second new thread is been getting injected. 30 seconds, new thread is injected. But the pool, since we are sending how many requests per second? We are sending 500 requests per second. So thread pool is gonna increase slowly, but every second, that's called burst load, right? Every second 500 new requests are coming, but dotnet thread pool is not gonna just simply allot 500 threads all at once. So it's gonna depend upon the config, right? Even though, look at my CPU is really low, my memory is really stable. So, but see, slowly increasing. And if I go back to logs, see, it's saying executing, it's kind of hang now. It's not returning anything. And some of my requests are timing out, saying that send timeout has elapsed. Why? Because if you go back here in the code here, if up, see, it's 2 seconds, right? So that thread might have been waiting for the IO thread the worker thread to get allotted to send this request to this service to get the response back. Remember, the ping service is only waiting 30 milliseconds, so that's out of the question. So now you can see this, that these logs are not literally printing anything now. 36 executing. And here, if you see here, the pool has now gone to queue length has gone to 21. So this pool, the thread pool queue length should literally be 0. If you don't have a queue length 0, that means you have a thread starvation problem, meaning that your worker thread should immediately get allocated and start working. The reason it is happening is that we are using a sync method here. So this CLI tool which I'm using has timed out, but on the back end you can see it does not wait for the response of the endpoint for forever. It just looks at the header, like if it is 200 or not. So you can see here in this endpoint that I'm using singleton client, and I'm just saying get data, right? And this is not it's just the contract of what we are getting is a string. You can look at like this. See, it's a string. Yeah. Come back here. So now we have literally an application which was hanging. Now, since all those requests which are finished, and some of them return successfully, but after very long time. And meanwhile, I have experienced all these send timeout errors on the WCF, which we did not experience when we were only sending how many requests. Here we send 500 requests per second, meaning 15,000 requests in total. Here we said, okay, 3,000, 100% response time, 100% response time. Here we got 0% response time. So you just observed a ASP.NET Core hang because we are using a sync method, right? Let's go back and see if this has stabilized. This has stabilized now. It is back to the 6, which is great. Is the log still going on? I just don't want to ping this thing again until it is stable. Otherwise, okay, looks like it is stabilized now. Go back to terminal. It's 2. Yeah, it has stabilized. Okay. Now I have written another method. Pure async, right? So here you can see that I'm using an async, but it is using a thread from the pool thread. Do I really want to do that? No. So let me just make a singleton here. I was The pool didn't work as I expected, but that's for, we will see how long this video is going to be. It's already like 20 minutes now. I'm still learning how to make the video small and crisp, right? So it is this. Now I will go back to the Docker. I'm just gonna put it down. I will have to start the dotnet counter again. Pure async, is it pure async? Yeah, everything looks good here. 10 seconds. Okay, good. Let's run this again. It's gonna be quick. I think our service is ready. Let's go back here, and we just gonna say dotnet dash counters -tor name dotnet. Yeah, it's waiting for the payload, and I'm just gonna send it. Yeah, we got. Okay. Now what I'm gonna do is go to the terminal here, and we're gonna say let's just warm it up. I'm gonna say 4 requests, and here we say pure async, right? If that's what the endpoint is, let's just double check pure async, and let's see. Go back to, so now we have 4 consistent, but we are not throwing much load. It is going on 30 seconds. Meanwhile, I'm going to show you a little trick, so you can even, let me in fact show you in my terminal. So dotnet counters, so you can list all the counter it supports. By default, it is not displaying all the counters, so you can use all these counters. If you're interested in specific details how you can use them, let's go back here. So this one is completed. You can put a comma separated in the double quotes with dash counters. That's out of the way. So we sent 4, pretty good. Let's go back to 500. Let's just crank it up, right? And that was the one which failed, right? Let's go back to Docker. You see here, now we're using pure async, but the thread pool queue is not jumping. And if you notice that the work items are getting completed, which is pretty great. And let me just, okay, let's set settle down. I think still going on. So we have 100% response now. Now I'm going to just change the dotnet counters a little bit. Queue clear. So it is waiting for the payload. I'm going to just increase it to even 1000, right? So you know it. You can see the requests per second here. So it's thousands right here. But look here, the thread pool queue is not jumping. So that's the advantage you will get when it is jumping the dotnet runtime, introducing a thread as it see fit. It is not always doing that like it was doing for every second, because the thread pool queue length was long. Now 70. So it does so when dotnet runtime, I think it detects blocking collection, like it can detect certain type of blocking requests. So here we are pretty good. Total requests 30,000. I think that's completed. 100% response. This will vary, right? So 99, max is 55. So 32 milliseconds we are blocking for. How many milliseconds here? 30 milliseconds, right? So here we are good. So we can even actually go even 2000 and it won't break. But the sync method will break very instantly, like it will go crazy. You can look at the logs here as well. This is a nice basic here. You can look at the logs like this as well, but it's going very fast. Let's go back to the containers here. See, 200. So That's the magic of async. So if you are converting your application from .NET framework and you are using WCF client, if you can convert the whole path to async, that's the advantage you are going to get. Your application will be more resilient. It's not gonna crash under burst load or something. I believe it can even serve like 6,000 requests or whatever. I'm just gonna throw the sync here. So that's one way. We'll see that how it goes. It goes crazy. So 6,000, you can see now the thread pool queue length has jumped a little bit, which is very interesting, but it is going to zero very suddenly. Thread pool is not injecting a thread. It might be because it's only milliseconds, and this .NET counter is polling the process every second. There is not an option to poll it like in milliseconds. I wish there was. Look at the CPU is jumping around as well now. So this is pretty nice actually. So this time 180,000 requests in total, but ratio success is 100%. There were some errors, I guess. I don't think so. Current failed requests are 0. Yeah, it stabilizes now. So power of async, you have seen it. For example, now you say, okay, I cannot convert for whatever reason to all the way async. I still want to use async pooled. I still want to use sync method. So there is a nice library. Let's just put it to test. It's called NITO async extensions. So you can use that, call it like this. Let me convert this to the singleton. We're gonna just stick with the singleton client today. Ping service client. I'm gonna get rid of this and make this client. Everything is happy, but I will have to down the Docker. Wait 10 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Start it again immediately. So what we're gonna do is we're gonna test the limits of async, that how this behaves. It is under the hood, it use a queue. It put every task in the queue, and behind the scene it executes in an async way, but it will wait on the front of the queue. That okay, when as soon as it completes. So let's go easy by 6 threads just to warm it up. Let's look at the tool here. Going good. Echo .NET counters. Oh, do I have a copy? I think I do. No, I don't. Let me just copy that. That is good actually, so we can see. Okay, are you still going? Yeah, it's still going. It's done now. Total request 25. That's it. Oh, because we sent only like 600% response. Okay. Now I'm not gonna go. Let's go by let's say 200 maybe. Let's see what happens. Is the thread pool queue jumping now? Right. Pretty stable. The last one, which pure async singleton. So we set singleton 500 and success was 0%. At 100 it was okay. Let's try 500 next time. So right now it's 200. 200 is gonna work fine. And the good thing is the thread pool is very stable and it is going down the sync. Good. So let's see if this can hold 500. That means you still have an option. I know legacy applications are hard to change. there is so much to look after. You don't want to break paid users. And if you have tests are gonna change. It's a big change. Though it's easy, there are plugins which can help you to convert all those calls to async, but still it's an effort. It's better to convert, but it's at the end of the day, it's gonna be your team decision what they will look like. So we can see the load is 500, and it is actually pretty stable. So use that. It is better than going sync all the way. Look at that, it worked. Let me go by 1,000 last time. Then we're gonna come back to. So look, it's very stable actually. I'm surprised. CPU is little bit higher than the async. It's 20%. Every second it's profiling, but everything else looks good. I think this is a very good trade-off. You can trade a little bit of CPU for the stability of your application, and it is going really good. So I would say this is a really good library. Though I am testing it only in a very minimal context. So you can install these packages, dotnet async context and dotnet async.task. All you gotta do is, where is the endpoint? Async singleton, async pool. All you're gonna do is, oh no, I always does this. We were using pure async. I was surprised by myself. So we have to use, I am so sorry, async pooled. That's the disadvantage of not writing script, right? Let's go by 10. See now 581, 5. Yes, then I will go straight to 500. I was excited for no reason. That's what happened when you get excited too early, I guess. 1, 2, come on, request rate 10. So 30 seconds is probably long. So okay. I'm just gonna go to the 500 just to make sure that it doesn't break like sync method. Let's see. Oh, the pool jumped right away. So nah, not really a good trade-off. I was excited for no reason. Testing the wrong thing happens all the time. Requests are arriving. You can see on the top. Request rate is now 2 per second. Really? No, not really. I think because of the queue length, it might not even responding to those. CPU is very low, meaning it is classic hang, right? Thread pool is 51, 52 every second it is introducing, but since we are sending 500 requests every second, it is drowning the server. Meanwhile, let's go to the Docker here and expand that. You can open a terminal here as well, and .net dump name .net .net. Oh, so I forgot collect. I can do that. So writing the full dump here in this file, and you can actually look at the stack trace. So I'm just gonna say .net dump analyze this path. It's gonna give me this help command. I can type it. I can look at tpq at that time it was taken, so it will show me the stack traces of all those things. You can see that it is request channel request, move request, Let's go to help again. If thread pool, so it is configured like that. Now worker total 118, idle minimum limit 6, so that's why we're seeing every second. And what other command does it have? And TKS, I don't think so. It's gonna print any. We need to let's go to thread pool. STPQ. So if we look at this trace, it's in the async task builder request channel, moving up. So you can analyze these here if you are really good at reading all this, but these can be opened, the dump can be opened in the Visual Studio as well, and as it can be opened in the Rider as well. Though on the Mac, the Rider is not really good at opening the dump. I tried earlier, it was not doing it. It was not doing a very good job. Anyways, let's go back to terminal. I just want to show you how you can take dump and then you can analyze it later. .NET memory is not available on Mac yet. I'm surprised. And let's see if the pool it has not calmed down yet. So yes, I thought that this will fix the issue of async, but it's not really good trade-off. You should test it according to your load, especially when your downstream service is more slow. So what is the solution? What I'm talking about? I am showing you all this stuff now, right? Before I show you, let me, in fact, what did I change? I don't want to keep this. I don't want to keep this. And did I make any changes? Yes, I did make any changes. So you can create this. Let me just revert this, roll back. So as early in the video, we talked about that you can override the config values of thread pool, right? So this is what we are doing here. It can be done in two ways. One is that you can do it by putting in the JSON here like this, exactly like name it exactly like this, runtime config template.json, and you can put 500 minimum threads, maximum threads 1000, and this is threads to add without delay, proc counter like 10. So there are other settings as well, which I'm gonna show you in the documentation here. You can just keep it for reference. For example, this is .NET counters, and here's you see all those thread settings here with very nice explanation that how those threads. So I'm just setting it up for the sync, how we can fix the still using sync because of X number of reasons you have for yourself that you want to go all the way async. And believe me, I maintain a legacy application. Sometimes those reasons are really, really valid. You don't have your team don't have a bandwidth. And some might call it, oh, now you always have some bandwidth, but no. So here, what I'm gonna do is I'm gonna kill this guy, and I'm gonna hit the singleton. It failed on 500, remember? So it is killing. But this time what we're gonna do is we're gonna go slowly, 30 second, and 3-4 tries. We will see that what's the outcome looks like, right? So meanwhile you can verify the files here as well. So show files. I just want to see that what's in the bin folder, release folder here. So once you compile, so this is your runtime template. What did we have in here? Just want to make sure it's 500,000. It is merged here in this one. So you can see 5,000, very good, right? So here you can see here as well. You can even specify these settings here as well in the CS project file as well. It will generate the runtime configuration file for you. So this is deployed, this is live. Let's go to the terminal and go to the pure async is all good. I want to go to singleton. Let's change it to warp interrupt. I will say 10, and then here we will say singleton, right? The video is already 45 minutes. Okay, let's go to the Docker here. Terminal equal $path. Let me copy that thing I have in here. See. Cool. So 10 requests per second. The pool looks stable. Everything looks cool here. I don't think so it's gonna have any problem. Now I'm gonna just straight go to 500. So on 500 it should not break at all. Let's see the jump 50, but look at the thread queue length here. It is still 0, right? And because these thread count is, instead of it being stuck at 6 and then injected at 7, what $runtime is doing, since we increase the min count, now $runtime is easily injecting it without waiting for the other factors. The CPU is low, the memory is stable. So that is a temporary fix, right? Temporary fix in a sense that if your application load is really stable, like you are not expecting burst loads or more customers overnight, and you don't want to change the application for whatever reason, and believe me, all those reasons can be valid. It's up to your team. So you can employ this hack, but be sure to test it under load, right? You want to watch your CPU because you are injecting threads. You only have limited number of processors on your host available. So anyway, it's gonna do the work in parallel on each processor and then do the thread context switches. If you introduce like too many threads just to counter every other endpoint using sync all the way, it's gonna blow back. You're gonna get more CPU usage. Make sure that your CPU is stable, memory is stable, and you're still surviving. So we go back, it's still 100%, right? 15,000 requests. I think we said 500, 2,000, right? So let's go by 1,000. So max is 1,000, right? So now the thread pool queue length is still 0. And we can see we are serving 1,000. Am I serving the correct one? Yes, I am. Let's go back up here, singleton, just to make sure. So it's using singleton, which is correct. So you see, even with the thousands, it seems like it is working, right? Yeah, the thread queue length is not jumping. It's 45 this time. I'm just gonna give it a try with 2,000 this time. See how the threads will jump. Go back. 121, right? See, that's how the minimum threads are immediately injected. But when we're looking at the without any changes, it was stuck at 6, 7, 8, every second it was injecting. Now it is using 121 threads to process the async. Like worker thread is blocked, but it is injecting it is 121 threads at work right now. Now, since the work has reduced a bit, I guess, so it came down to 96. It recalibrated itself based on the work it has and number of threads. $runtimes one thinks that are sufficient, right? So the queue length is 0, which is the ideal measure. We can see the request rate is dropped to 0 now. Success. So if you have this situation, You are using the sync method here. Even this will even save you if you are using, like, let me go to the pure async, right? So if you are using a pure async, but you are not using async method here, you are using dot result or get awaited dot result. There is so much debate about this. They are not any different. It's just that the exception are gonna be better in this method. So I'm just gonna use that. Even with that, if you use pure async with the better thread pool configuration, you can set it here. See, watch this space as well, that you don't want any threads delay, and test it under load when the minimum threads are reached or max threads are reached, and name it like that. If you don't want to deal with this, you can just go ahead and put it here and follow the documentation I showed you on this link here. Thread injection here. See this? I wish there was a way to share on the video, right? And you can read more about all those tools here. We use the dotnet temp, and we use them dotnet counters. There is a stack. These are very good tools if you understand the memory management or the profiling way of doing things. So the async is always better, and this solves the problem, right? Now we are able to let's push it a little bit more, right? I just want to see that how far this can go, right? 3000. I want to break it. Ooh, thread pool jumped. See? Now it is going to get into the hang position again. So far it is sending out now. See, you see all those send timeouts now? 200 send timeouts. It might have calibrated itself. So the count has decreased to 0. That's why it is saying, okay, I introduced 516 threads to manage your load. But that guy is not waiting. So yeah, it is better. It is coming down. It is, I guess, stabilizing. That we can see the logs here. Some requests are sending 200, but just remember, it is all of a sudden now like pushing it out. Request finished. I guess the context switching was not available because there were so many threads with a limited profile. So if your host has like 4 processors, it's gonna by default, I guess, use 4 min threads. And if you're using anything, then you should not have any problem. Unless you have, then you can tweak a bit, tweak the settings. Don't go just high. In one of the application I maintain, I'm using up to 200 max threads and 100 or 120 minimum threads. It's not in the framework application yet, but it works really nice. It can serve with 8 web servers with 4 cores each. It can serve up to 800 concurrent users, and it has a lot of complexities around. It communicates with the stress service, WCF service, SOAP service over a bunch of other stuff like S3. It's fairly complex application. What else I want to show in this video, which is already like 50 minutes long. I hope you will like it and you have learned something. Just to recap, right? We have seen what are the ASP.NET hangs. General known is that if you are using this method or dot result, it's gonna block the worker thread until it is out. Meaning, if there are no threads available, that can even occur a deadlock, right? So, or it's gonna hang and just interrupt all your application. If your downstream is slow, we haven't looked at this. For example, I am using 30 millisecond. If I increase it to like 500 millisecond, right? So that what that means is we are using sync. So the worker thread is going to be blocked for 500 milliseconds. So 500 milliseconds, the thread is, doing only one thing and waiting. And if more threads are arriving, who is going to serve them? Nobody, right? Because there is no capacity available based on the config. So it's gonna throw even more errors. So since this is a constant latency, here it for the purpose of showing you how it impacts your application performance and stability. If it is variable latency, then your application will blow at unexpected moments. And logs don't help much. It can give you context, but not every single time. This Docker is really nice to experiment with it. I'm really new to the Mac and using Docker as well, but this is nice, nice Docker. I will push all these changes later, and you can find it in my blog. I'm writing a blog along with it, but I'm still trying to build a story. It looks nice so far. I'm planning it to publish it in coming days. Well, thank you so much for watching all the video. I hope you have learned something new today. And if you like, you can subscribe my channel. It gives me just a little bit boost to record another video. Awesome. All right. Thank you so much. Take care. Bye.